We discussed in the first part, we discussed the Coulomb's law. We wrote it down. Then the question was saying that a charged sphere X is supported on an insulating stand. A second charged sphere Y is suspended by an insulating thread so that sphere Y is in equilibrium at the position shown. This was the diagram, and there was a separation between the two charges. We started this question and we rolled it down and we said that this is the resolution like AS physics. There are forces acting. These are the forces acting. These are the forces acting on this sphere. These were the forces. And we first applied trigonometry to find the angle theta. Then we had applied the Coulomb's law to find the force. Then we used our AS physics logic of two equations, solving them simultaneously. We found the mass of the sphere. We were here. Now, I'm starting from part number 3. Calculate the total electric potential energy stored between X and Y. Let us quickly recall the formulas. Look at the formulas. This is Coulomb's law. The formulas, three formulas for electric field strength. Now the fifth formula is also electric field strength. Now electric potential. There are 1, 2, 3 formulas for electric potential. Then electric potential difference. Then electric potential energy U. Q upon 4 pi epsilon naught into R. This is the difference of electric potential energy. I have posted the formulas for AS physics electric field and A2 physics electric field. We need to find the total electric potential energy stored between X and Y. You people have to help me in the formula working. U is equal to Q1, Q2. Let us do it in terms of K upon R. The value of K is 9 into 10 power 9. And then we have two charges, 96 nanocoulombs. So I will convert them into coulombs. So 96 into 10 raised to power minus 9 and 64 into 10 power minus 9, 0.08 square. Now, this is the formula. Please copy down the formula. Today, even Ahmed is not there. So you people have to help me for calculation.
(8.64 into 10 exponent negative 3).
8.64 exponent, how much?
Negative 3.
Okay, very good. Okay, other people can also please give me a point here. The other people should also find out the answer and verify. You can okay on the mic. If you want, you can okay on the chat also. 6.9. Okay. But I'm getting a value in 6.9. What is the issue now? Oh, this is the issue. Okay. There is no square in the formula. There is no square in the formula. So please calculate again. The formula is only R.
6.9 into 10 exponent negative 4.
6.9 into exponent minus 4. Okay, this is the answer. And then the question, this is the AS version of this chapter. An electron enters the region between two parallel plates P and Q. Two parallel plates P and Q that are separated by a distance of 18 millimeter as shown. The space between the plates is a vacuum. The potential difference between the plates is 250 volt. The electric field may be assumed to be uniform in the region between the plates and zero outside this region. And zero outside this region. State the direction of the electric force on the electron when between the plates. The top plate is positive. This plate is positive. Look at this plate is positive. And electron by nature is a negative particle. So now, state the direction of the electric force on the electron when between the plates. When this negative particle enters, let me draw it here. Okay, now this is the charge particle. The top plate is positive. So where will be the force? The in electric field, in an electric field, the force is always parallel to the field. But will it be upward or will it be downward? So electron is entering the field. So will it be will the force? Okay, what's the answer? Downward. Why downward? Electron is negative. Faisa, please look at the. It's negative.
Upwards.
Upward is a good answer, but other people should also take part in it. These questions are never difficult. If you do not want to speak over the mic, you can write the answer in the chat, because past paper is not solution. Everyone has the marking scheme. Solutions are also available. So the main issue is not the answer. Main issue is the contribution. That is why on campus is much better, because we can talk, we can take up the feed. It will deflect towards the positively. That's a good answer. So the electron force, the electric direction of the electric force. So you can mention towards the top plate. Towards determine the magnitude of the force acting on the electron due to the electric field. You people have the formula book. In this chapter, you have to memorize the AS formulas and A2 formulas both. So I can write down the formula. First, I will write down E is equal to V upon D, electric field strength between the plates. E is equal to V upon D. My potential value is 250 and 18 millimeter. So I will write 250 upon 18 into 10 power minus 3. Then F is equal to QE. First, anyone can help me? 250 upon 18 into 10 power minus 3.
1.4 into 10 exponent 4.
Can you repeat? 12 point?
1.4.
Okay. Other people should also take part. 1.4 into 10 power minus.
No, only 4.
Sir, positive 4.
Acha. No. Acha, you mean, oh, okay, I got it. 1.4, 10 power 4. Unit, I will say volt per meter. Acha, what is the charge of an electron? Fixed charge?
Minus 1A.
But in terms of coulomb, it will be 1.6 into. Now look at this working.
Two point two five, 2.24 into 10 exponent negative 15.
This is the value here we are getting. In terms of significant figure, this we can round the answer looking at the question. The data in the question is correct. The data given in the question is correct up to 2 sig fig. They can go, they have gone to 2 sig fig. So that's a good calculation support. We got 2.2 into 10 power minus 15. Now, this is a very technical question. Why the electron does not follow a circular path? This concept was explained in our chapter called circular motion. Now, this is a circle, and something which goes in a circle is possible when the velocity and the force, look, this is velocity, and look at this is the force. Velocity and force are perpendicular. This is a very important and very interesting concept, that force and velocity are perpendicular. Here, if you see the diagram here, the velocity and force are not always perpendicular. That is why it won't be a circle. Force and velocity are not always perpendicular, are not always perpendicular to each other. So path is not circular. Now look at the book you people have, and you people can find another question for me. Is there any question in 2024? Can anyone check if there is any question in 2024? Do let me know, please. Open your book and find electric field 2024 question. Any 2024? If anyone got the if anyone could get the value of any question in 24, let me know. Well, I got a question November 23 41. November 23 41. Please open the file. November 23 41. November 23 41. Question number 5. So we got the question here. November 23. Good answer. But you should write. You have to write the full answer. Electric potential at a point. So you have to write. Please write with me if you people have your own books. Electric potential. This is, if you people can open this in your file. This is November 23 41 and question number 5. Okay. Electric potential at a point in an electric field is the is the work done per unit charge to bring the charge from infinity to that point. That's a good point. If you mention positive charge, that's a good point. Because why I haven't mentioned, because by default, when you say the word charge, it's positive. But if you say bring the positive charge, work done per unit positive charge, it's very good. If we do not mention, it actually means by default positive charge. Okay, now let's move to the next question. Two isolated charged metal sphere X and Y are situated near to each other in a vacuum with their center a distance of 24 meter apart. Point P at a variable distance x from the center of sphere X on the line joining the center of spheres shows the variation with x of the electric potential V due to the sphere at point P. We have done a question similar to that some times back. I feel we have done it in another class, and there were two spheres. So now these are the two spheres, and if I simulate the diagram, please draw the diagram with me so we can simulate this question. So these are the two charges, two metal spheres. And the separation between their center, the separation between their center is 24 meter. And this is a point P at a variable separation, which is X. There are two metal spheres with charges. So I have made a diagram. Okay. This shows the variation with X of the electric potential. Acha, V is a scalar. V is a scalar. Its basic plus minus depends upon it is increasing or decreasing. What was the theme? If you are going in repulsion, V is positive. If you are traveling towards attraction, V is negative. I repeat the convention for understanding this question. Actually, this question has a zero value here. It has a positive value and it has a negative value. At this point, V becomes constant, and here also V is constant. Now, what was the theory? Where V becomes constant? V becomes constant when you are traveling inside the sphere. So let us recall the important concept. V is constant when point P is inside a sphere. Then we can put a test charge, assume a test charge positive Q at P. Let us put up test charge on P. Acha, positive potential means you are going in repulsion because V increases. Negative potential means you are going in attraction and then V is negative. So when V is positive, it is a situation like this. And when V is negative, then the small charge is moving towards a negative charge, and it is basically a case of potential is decreasing. So these are the three important concepts I want to recall. Now you have to see this whole, and now look here. State three conclusions that can be drawn about the spheres. The conclusions may be qualitative or quantitative. You people might remember a very similar question we did in a class. Okay, now I will wait for the features. First of all, can you people identify if I'm traveling? If I am traveling in this direction, how I know that I'm traveling in this direction? Because x is increasing, so it means I'm traveling from x to y. I am traveling from x to y, x is increasing. When I travel in this direction, x increases. So I'm traveling from here like this, x is increasing. X is increasing. So till this 12, V is positive. After 12, V becomes negative. So can you people read for me what is the radius of the first? What is the radius? But first of all, where is the radius? This is the, now this is the radius. Can anyone read this number? Is it between 0 and 4? So can
2
we say
meter.
2 meter?
2 meter.
2 meter. Okay. And then you can read the other side. Radius actually comes in where the potential, where the potential is, where the potential is constant. So here it is 20 to 24.
4
4
meters.
meter.
Hmm. Yes. Okay. So this will be the 4 meter, one of their favorite topic. This is a question, hollow sphere question, which is one of their favorite topic, which comes always. So this is 4. It is a point when less than x is less than or equal to r as a value. So you will say that sphere x radius is equal to 2 meter. Sphere Y radius is 4 meter. We are having a negative sign when we are traveling from 0 till 12. So you will mention that x is equal to 0 to 12. V is negative. So sphere x is minus. Beyond this, V is positive. So sphere x is negative and sphere y is positive. Now, where the potential is 0, 0 till 24 patch, the potential is 0 exactly in the middle. So you will mention V is 0 at x is equal to 12, midpoint midpoint of the line 24 meter. So how it is possible that the potential is 0 exactly in the middle? So the two spheres carry the same amount of charge. Their charges are equal. A positively charged particle is placed at point P in B such that x is equal to 12, the particle is released. X is actually this is the midpoint. This is a midpoint. The subsequent motion of the particle. Left particle is negative, right particle is positive, Q is positive. So let us formulate his story now. We have a positive sphere. We have a left sphere is negative. Right sphere is positive, and we have exactly in between a positive sphere. So what I was thinking that if the separation between them, look, the separation between them is 24. The separation between them is 24, and this is a small particle q. Left particle is minus, right particle is positive. So can anyone tell me that will this particle experience a resultant force? We have discussed it in between the two plates case. This is 12 meter. Now positive repulsion and plus minus attraction. Look at this. So can you people tell me that the resultant force is to the left? He says describe and explain. So now look at this working. Okay, so we have done this question also. This is a complete question. We did it and we have good response today. So